So this is homework 8 for year 11, the hint video. If you're stuck, watch this. If you're still stuck, you need to come and find me before the deadline. Question 1. It's all about working out the internal angle of this octagon, and if you remember what I taught you in class, you actually work out the external angle of a shape first. It's going to be 360 divided by the number of sides, and it is an octagon, don't forget, so it has 8 sides. Once you've done that, you can work out the internal angle by taking it from 180, and that's because they are on a straight line, and so the internal and external are always a pair of angles that add up to 180 degrees. Once you've worked out that, you've got this angle x here. Now that is going to unlock how to find theta as well, because if you remember from what we did in class, angle x is also here, whatever x is there, it's also there, and it's also there. And if you remember as well, we talked about this when we did a couple of examples in class, this angle on this side is actually going to be theta as well. And so if we just highlight the shape, just this part of the shape here, it's got 1, 2, 3, 4, 5 sides. So it's actually a pentagon. So this pentagon here, its internal angles will add up to a number that you can work out. And then don't forget you've got this angle, you've worked it out, this one you've worked out, and this one. And that should be enough to work out theta. Think about what we did in class. So if we move on to question 2. Question 2, I can't give too many hints without actually telling you exactly what to do, so I will say if we just concentrate on just this right angle triangle here, I know one angle on one side, so I could work out this side here using trigonometry. And actually once I've done that, I've got a different right angle triangle, but I'll know this side here. I've got this other right angle triangle, and I'll know one side and the other side, so it should be fairly straightforward to work out that missing side. So that's how you do that question. On to 3. Sum of the internal angles of an 18-sided polygon. Well, there's various ways of doing this. One way of doing it is to say 3 sides adds up to 180, 4 sides adds up to 360, 5 sides adds up to 540, etc, etc. You could keep going like that. Or there is the other formula that we talked about, the n minus 2 times 180 formula. You could use that to solve that problem as well. So that's one way of doing it, and you will get there. Question 4, how big is one internal angle on a regular 10-sided polygon? Well, you're going to do the same as we did on that first question. External first is 360 divided by sides. Once you know external, take it from 180 to find out the internal. And then question 5 is going to use this rule that I just wrote down, but in reverse. It says how many sides has a polygon got if the outside angle is 5? Well, you can use this rule in reverse, and you can say sides is actually 360 divided by that exterior angle, and that will get you what you need there. On to question 6. This is a question about internal angles as well. If you think about it, the internal angle, let's start with this hexagon. The internal angle of this hexagon, you can work that out fairly straightforward, and that will be here. So just imagine you've worked that out, and that's there. Then working on the pentagon, the internal angle of the pentagon, if you work it out, they're all the same because it's regular, and actually that will be here. So you can work out the hexagon's internal angle there, pentagon's there, and of course these 3 angles add up to 360, so you can work out the missing one. That's how you do that. Into question 7. Factorising a quadratic. This is going to require a little bit of thought. If you've got stuck on this, this is probably something you need to practice. I'll show you how to do one. So let's say I was going to try and factorise this one here, and you'll notice it's different to the 2 actual homework questions. But if I show you this example, maybe it'll be enough for you to do questions A and B. So this is how I would factorise this, and there's more than one way of doing it, but I'm going to go for the method called splitting the middle term. So the first thing you do is write this little table, A times C, and then you've got B here. Now AC in this question here, bear in mind A is 3 and B is minus 5. AC is minus 15 and B is the number in the coefficient of x, so it's minus 2. Now what I need to do is I need to find a pair of numbers that multiply to make minus 15 and add to make minus 2. So if you think about it, numbers that multiply to make minus 15, minus 1 and 15, 1 and minus 15, 3 and minus 5, minus 3 and 5. I can't think of any more. And if I try and decide which one, does that add up to minus 2? No. No. Yes, this one does. So it's actually 3 and minus 5. So what I'm going to do is I'm going to use 3x and minus 5x. And those two values, those two terms, are going to be used to split this middle term up here. And it doesn't matter which order you put them in. So I'm just put them in the order I've got them there. So 3x squared. I'm going to use these two, 3x and minus 5x, these two terms I've found. So 3x minus 5x minus 5. So those go there. And what I've actually done, to be clear, is I've split this middle term up into these two parts here. Now I'm going to factorise just this first section. You'll notice they both divide by 3x. So watch this, 3x, x plus 1. And then my other bracket needs to be x plus 1 for this to work. So you need to think about how to make that happen. And it's going to be taking a minus 5 out of there. That works. Finally, the answer comes from this bracket here, and the other bracket is made up of these two parts. So you end up with an answer on my question of 3x minus 5 and x plus 1. If you expand that back out again, you will get the quadratic that I started off with here. So that's how you do an example. Try and use that technique to do A and B. If we move on to the next question. Now this is a question about machines doing work, and we talked about a clever way that a student in a different group had done this. And so let's see if we can use this technique again. 4 days to complete a task. That means that in 1 day you do a quarter of the work. So I'm not going to do all of this, but I'm going to get you started. If all the machines are working, 1/4 of, in quotes, the task, whatever it is, 1/4 of the task takes 1 day when all machines are running. Now if we read the question, it actually says that half the machines are running for 2 days. So that is actually the same as this. Half the machines for 2 days is the same as all the machines for 1 day. So this thing here is actually a quarter of the task. If a quarter of the task is complete, then 3/4 of the task is still to be done. And you need to think about how long 3/4 of the task would take if all the machines get involved again. And it all comes from this fact here. So that's as much as I'm going to give you. You might need to listen to that again and think about how that works. Let's move on to the last two questions of this homework. First one of these, question 9, is the cosine rule, and that is a major hint. It doesn't say that in the exam, you're not going to be told that, but I'm trying to help you do your homework here. So, cosine rule. Let's call the side opposite the angle A. So, A squared equals B squared plus C squared minus 2BC cos of the angle in the question. So, let's just say what's what. This is side A. And this is angle capital A. That makes these two sides here, sides B and C, and it doesn't matter which one's which. So A is the side I'm trying to find. Capital A is this angle 20 degrees. B could be 5 and C could be 6. If you substitute all of them into here and carefully type it into your calculator, you'll get the value A squared. And of course you need to square root that to find A. That's called the cosine rule. It's used on non-right angle triangles. And you always use it in this situation when you've got a pair of sides and an angle given in between, like that. And then the last thing to say about question 10, without me telling you how to do it, is the following. Bearings work like this. You go to the place you are leaving. Let's read this. It says A from B. So I'm actually going from B. I'm going to A from B. So I'm actually going, I'll draw this, I'm going along this line here. Let me see where I'm going. I'm going from A from B, so I'm going along there like that. Now to find a bearing, you always go to the place you are leaving, and you go north, and you go clockwise. Like that. That should be enough information for you to work out the numerical bearing in this question. You don't go that way, that's anti-clockwise. You go from the place you are leaving, and you go clockwise around like that, and you work out what that angle is. So you should be able to do that question now. That is the end of the homework. Remember, you should really do every question. If you get stuck, it's not acceptable to just miss it out. You need to come and see me and ask for help. And some people are doing that and some aren't. So can you try your best this week, please? That's it.